Okay, this is the video for Learning Target 1 and 2 notes for the Rational Expressions unit. It's going to be a condensed version of what we did in class. In fact, I'll probably skip several parts of the notes just to get the video down to more like 10 minutes to 15 minutes. I still don't know if that's possible, but we'll give it a shot. The new unit's all about fractions, and the first page of Learning Target 1 and 2 notes is dealing with what you can't have in a fraction. 1 over 2 is okay. Negative 1 over 2 is okay. Negative 2 over 3 is okay. 0 over 5 is okay. But if you'll recall, you cannot have a 0 in the denominator of a fraction. So that's what this entire front page is about. First of all, the way it will ask the question is it will say state the excluded values for the rational expression. A rational number, remember, is just basically a fraction. So I've reminded you how to solve equations, solve quadratics. That's something you can look over. But the examples are here, 1 through 5. The directions they state the excluded values. So here's our example, 2 over x. The excluded value is whatever would make the denominator become 0. So what would make x become 0? Well, x being 0 itself. So that can't happen. So we write it like that. X cannot equal 0. Try to get our pen to stop doing the crosshairs. I don't guess we're going to get to. The second example, p plus 3 is the denominator, so it can't be 0. So what would make p plus 3 equal 0? Subtract 3, p being negative 3. So that can't happen, so we say that p cannot equal negative 3. So again, we're just stating the numbers that the variable can't represent, what we have to exclude, or it would make the whole rational expression undefined. So if we look at number 3, 3 times x plus 4, if you think about that denominator not equaling 0, then 3 will never equal 0. But x plus 4, if we use the zero product property, an x value of negative 4, when you add 4 to it, would make 0, so x cannot be negative 4. And similarly, number 4 down here, x plus 2 and x plus 1, that denominator cannot equal 0. So the zero product property would say, all right, well, x cannot be negative 2 and x cannot be negative 1. So x cannot be negative 2 and x cannot be negative 1. And then finally, number 5, the zero product property here, again, would say x or x minus 5. Neither of those can be 0. So x can't be 0, and x minus 5 can't be 0, so x can't be positive 5. So that's the first page, excluded values. This is old stuff, so I'm not going to really mess with that. I'll move on to the next page. Quick reminder of what you can do with fractions. When you're multiplying 2/3 times 5 over 6, you multiply the tops. 2 times 5 is 10, 3 times 6, 18. And the reason you can reduce this is because you can write this as 2 times 5 over 2 times 9, and the factors 2 will reduce, leaving you with the answer 5 over 9. That word factor is huge for what you can reduce in fractions. The second example of previous knowledge, how do you divide fractions? Well, you take the first fraction, 9 over 10, and you multiply it by the reciprocal of 6 over 5, so you multiply it by 5 over 6. Multiply the tops again, so we get 45. Multiply the bottoms, 10 times 6, and we get 60. And that reduces because 45 is 15 times 3, and 60 is 15 times 4. So the factor 15 reduces to 1 over 1. And the final answer, 1 times 3, 3 in the top, 1 times 4, 4 in the bottom. Now, I've been using the words top and bottom because they're easier to associate, but the correct word is numerator and denominator. So we need to work on the vocabulary too. Numerator is the top, denominator is the bottom. Not going to read these directions to you, step 1, step 2. I'm going to talk about them as we do problems, but they're there in case you forget. But there are 2 directions for these problems. Simplify each and then state the excluded values. I want a disclaimer here. We are not going to state the excluded values, not for any division problems. I won't ask you that, okay? All right, so number 1, how do we multiply fractions? A fraction times a fraction? Well, one way is to multiply the tops. 8a cubed times a squared is 8a to the 5th. And then multiply the bottoms. A to the 5th times 4a is 4a to the 6th. And then this is an old problem, nothing new here. We can reduce 8 over 4 because they have a 4 in common to 2 over 1. And we can reduce a to the 5th over a to the 6th to 1 in the top, a in the bottom. So what's left? 2 times 1 in the numerator, 1 times a in the denominator, so 2 over a. Now I'm not going to do the next one, number 2 there. If you multiply the tops, you'll get b to the 6th, c to the 5th. If you multiply the bottoms, you'll get b to the 6th, c to the 9th, and then you'll reduce like you did here. Let's do one of the division problems. Let's do the harder one. Let's do number 4. So to divide, we'll take 7x cubed y divided by x squared y to the 5th and multiply it by the reciprocal of the second fraction. So that means flip it. X to the 4th y squared over 21 xy. I'll go ahead and multiply the tops. 7 times 1, 7. X cubed times x to the 4th, x to the 7th, y times y squared, y cubed. And then divided by 1 times 21, 21. X squared times x, x cubed. And y to the 5th times y, y to the 6th. And then several things reduce. First of all, 7 over 21 is a fraction that reduces to 1 over 3. The x to the 7th over x to the 3rd reduces to x to the 4th over 1. And y cubed over y to the 6th reduces to 1 over y cubed. I'm not spending a whole lot of time discussing why it reduces to what. If you have trouble with that, come talk to me about it. But that's old material, things that we did in the polynomial unit for monomials. But we are going to get a final answer here of 1 times x to the 4th times 1, so x to the 4th in the numerator, divided by 3 times 1 times y to the 3rd, 3y cubed. All right, next page. We finally get to learning target 2, which is simplifying and stating excluded values for for rational expressions that have polynomials in them. So binomials, trinomials. I should have said this earlier, but the learning target 1 was strictly monomials. So no addition, no subtraction. Now we're starting to get addition and subtraction, but it's much the same as what we just did. You got to remember the word factor. The things that you can cancel are factors. So I've reminded you here in this box how to factor things from our polynomial unit and our quadratic unit. But let's take a look at number 1. Simplify each rational expression and state the excluded values. Well, for starters, we can simplify by canceling factors, just like the last 2 pages, or just like the previous page. The trick is recognizing that the multiplication sign in number 1 is in between the parentheses, there and there, which means that x minus 2 is a factor, x plus 2 is a factor, x minus 2 is a factor, and x plus 5 is a factor. So what factors do the numerator and denominator share? They share an x minus 2. So you can literally cancel the factor x minus 2 in the top and bottom. It reduces to 1. And it leaves you with the factor x plus 2 divided by x plus 5. Now, a common misconception is that people get in the habit of canceling the x's and canceling the factors, and then they kind of want to cancel these x's in this answer. But you can't do that because they're not factors. You see the addition here between x and 2? That makes x a term, not a factor. Another explanation for that is down here at the bottom in highlighted. You're welcome to read through this. It kind of explains and kind of gives you an example of if you put 1 in for x here and here, it just doesn't work. All right, so I'll let you read through that, but you can't cancel the x here and the x there because they are not factors, they're terms. So number 2, I'm going to exaggerate the multiplication in number 2. There is 2 times x times parentheses 3x minus 1 divided by 10, which I'm going to rewrite as 2 times 5 because there's a 2 in the top, times x squared, which is x times x, times 3x minus 1. So the factors of the numerator are 2, x, and parentheses 3x minus 1. The factors of the denominator are 2, 5, x, and parentheses 3x minus 1. So the factors that you can cancel that they have in common in the numerator and the denominator are the parentheses 3x minus 1 factors, they reduce to 1. The pair of x's here reduce to 1. And the pair of 2's reduce to 1. Leaving you with the answer, well, 1 times 1 times 1, just a 1 in the top of the fraction of the rational expression, and a 5 times an x in the denominator, so 1 over 5x. Now that's just the simplified part. We haven't stated the excluded values, which is something I think we probably should just save for a more in-depth explanation when you come back to class after watching the video. But I'll give you the quick version. The excluded values are what would make the original problem undefined. So if I look back at number 1 and number 2, let's start with number 1. The parentheses x minus 2, that factor in the denominator, and that factor x plus 5, those cannot equal 0. So the zero product property would say x minus 2, what would make that 0? An x value of 2. So you need to exclude x equals 2. And you need to exclude whatever would make this parentheses become 0, and that would be x can't be negative 5. That was just kind of like the first page of the notes, but this one's a little trickier. X squared, what would make it become 0? An x value of 0. And what would make this 3x, what would make the 3x minus 1 become 0? Well, that would be add your 1s, divide by 3. X cannot be 1/3. All right, that one's kind of weird. If it doesn't make sense, ask me about it when you get back to class. And then we're going to finish this off. I'll do 3, 4, and 5 because of the introducing factoring again. And then we don't have too much left in the notes. So let's go ahead with number 3. X squared over x squared. Some people, when they simplify, they might think, well, those cancel. But remember, those are terms, not factors, because they're separated by subtraction. So the first step is to factor the numerator and factor the denominator. The numerator is x squared minus 25, and it factors using the difference of two squares to x plus 5, x minus 5. If you need help with the factoring, we need to watch another video, or we need to come in for tutoring to get that help. The denominator factors using GCF to x times x minus 5. And then the factors x minus 5 will cancel, giving us a final answer of x plus 5, running out of room here, x plus 5 over x. Number 4, the denominator factors to x plus 2, x minus 2. The numerator is still x plus 2. So it might help if you put your own parentheses around that x plus 2 in the numerator so that you can see that it's a factor of x plus 2. So the x plus 2 in the bottom and the x plus 2 in the top reduce to 1 over 1. They cancel. So our final answer is 1 over x minus 2. In number 4, the top 2x minus 14 factors because it has a GCF of 2. Factors to 2 times x minus 7. The denominator factors to two binomials. I call it LOI. Factors to x and x. So think about FOIL backwards. What would multiply to give you negative 14, but add to give you negative 5? That'd be negative 7 and positive 2. And then the x minus 7's cancel. And we get the answer 2 over x plus 2. Be careful. Some people want to cancel those 2's, but you can't because 2 is a factor of the top, but it is not a factor of the denominator. It's a term of the denominator. So final answer. All right, last page, we won't do all of these. I want to remind you of one more previous knowledge. You can also multiply fractions by reducing on the diagonal before you do any multiplication. So that could reduce to 1 and 3, and then you multiply the numerators and multiply the denominators. So 1 times 5, 5 over 3 times 3, 9. Division, well, you can reduce the 30 over 20 to 3 over 2 because they have a 10 in common. But how do you divide 3 over 2 by 3? You multiply by the reciprocal, which would be times 1/3. And then you might notice that you can reduce on the diagonal. And then you can multiply the tops, 1 times 1, and get 1. Denominators, 2 times 1, 1/2, final answer. So that's all rules of fractions that you learned in a previous year that we're going to use in the next problems. So I'm not going to read the steps again. You're welcome to read them. We'll talk about them here. So number one, you can reduce on the diagonal, or you can go ahead and multiply the tops and multiply the bottoms. All right, I'm going to go ahead and multiply the tops and the bottoms for this example. I'll do more reducing on the diagonal and some others. So if I multiply the top of this fraction, x plus 1 times 6x cubed, I'm going to leave it as 6x cubed times parentheses x plus 1. I'm not going to distribute because it helps to see this in factored form so you can cancel the factors. If you were to distribute the 6x cubed to the x plus 1, you would eliminate the factors. It would be an expanded form. It'd just be harder to see what cancels. But when you have the denominator, 2x times 3, I'm going to go ahead and multiply that and make it 6x because I'm going to be able to cancel the 6's and cancel one of the x's. But then times x plus 1 as well. And then you see a lot of things that are going to cancel. The factors 6 reduce to 1. The factors x plus 1 reduce to 1. And then the x cubed over x reduces to 1 in the bottom and x squared in the top for a final answer of x squared over 1, or just x squared. Division, you multiply by the reciprocal. So multiply by, flip the b over b plus 3 to the denominator. And now I'll cancel on the diagonal for this one because the b plus 3 factor on this diagonal and that diagonal reduced to 1. And we get 3 times 1 times 1, 3 over 5 times 1, 3 over 5. All right, now the last two, I'm just going to do number 4. You could do number 3. Make sure that you multiply by x squared plus 7x plus 6 over x plus 1. So make sure you flip that second fraction. Okay. But number 4, if I factor 8x plus 6, they have an 8 in common. GCF becomes 8 times x plus 2. I look on the diagonal and I see 4 and 12. I see that they have a 4 in common. So I take that out. I see a trinomial that factors using what I call LOIF. Ooh, didn't leave much room there. To x plus 2 and x plus 1. And now I'm going to reduce on the diagonals if I can. Let's see. I see an x plus 1 that will reduce to 1. I see an x plus 2 over an x plus 2 that will reduce. And I'm going to pretend that's all I see. So let's multiply the tops. 8 times 1 gives us 8. And the bottom is 1 times 1 times 4 times x minus 3. So that's 4 times x minus 3. So I didn't see the 8 and the 4 on the diagonal, but now I see an 8 over a 4, so I've still got to reduce that to 2 over 1. So your final answer, 2 over x minus 3. All right, so that's about as quick as I can make the video. You might want to, read back through some of this, check some of the step-by-step, and then, do what you can with it, but then come in and ask questions if you still have questions.